Welcome, everybody. Thanks for joining the session. It's an honor to be the speaker of the first SeaTunnel meetup overseas. Quickly, who am I? My name is Wang Yang. I'm a data engineer in Shopee data infrastructure team. Primarily work on Spark-related application development. Before we talk about SeaTunnel, let's take a look at what problems we were facing and why we choose SeaTunnel as our final solution. Third part, we'll talk about what we have done for our internal SeaTunnel. And based on this internal version, how we provide a short-term solution for our end user as soon as possible. Apart from that, we use the internal version to refactor one of our current systems. Last part is about how to integrate SeaTunnel into our brand new product and improve user experience. Shopee is an e-commerce company, and we are providing services for people all around the world. So terabytes of data are generated each day. To enable our business getting insights from data, Shopee has been working on building our big data platform. As you can see, we have provided different tools covering whole life cycle of data development. Components that I have highlighted with yellow color are in charge of generating data. Ingestion jobs are managed by Data Hub, and in Data Studio, user can browse data, create non-standard data pipelines from ingested data. After jobs are created in Data Hub or Data Studio, scheduler will run this job at certain time as expected. Now, there are quite a number of jobs already created and running. Tens of thousands of them are running every day, including batch ingestion and continuous ingestion jobs that are running in Data Hub. Continuous job is near real time. They use change data capture related technique and sync data into data lake. Real-time ingestion basically is sync job running in our Flink platform. And internal ETL jobs are usually created by user in Data Studio. Most of them are used to build our data warehouses table based on original data. Things looking great so far, but there are still many existing jobs haven't managed by our platform and couldn't be migrated into our platform. Because of that, we spent lots of time creating and maintaining them, resulting in we couldn't meet our users' requirements in time. There are many reasons we couldn't make it. Let's take a look at them. As we mentioned above, our platform handles some types of ingestion already. They are most frequently requirements, but supported data sources are limited, mainly are MySQL and TidyDB. Besides, we need to make sure these data sources are standardized, which means they are managed by DBA, so that things like sharding table names are following certain conventions, and schema shouldn't change too often. Obviously, there are still many data stored in different local regions. These sources are not having same conventions. We couldn't build standardized product for them in short time. As you can see in the picture upper right, we call these non-standard data sources as third-party data sources. And these are many different kinds of them: FTP, API, S3, CloudDB, etc. Apart from importing data to Hive from external sources, big data stores like ClickHouse, Druid are used by many teams for its specialties. Data in these components are usually exported from Hive, but some of them need to sync data to Hive as well. Currently, each of these component pair has independent transport component. Basically, each of them has a code base. So it brings developer many trouble in communication and learning each of them. Second problem is we have variety of data cleaning and treatment requests. There are three aspects of this problem. First one is we are lack of way to do data cleaning, aka transformation. Most of our raw data needs to do data cleaning, parsing, data convention, conversion, and column, like region or date time before actual analysis. But each of transport components provide limited and unique way of data cleaning procedure. Second, users don't have convenient way to build data warehouse. Currently, users are self-maintaining all the data treatment case by case in our data studio, and it takes large data processing effort. Most users are still using ingested ODS table directly. Lack of unified way to build data warehouse tables. And last, we have complex data transformation like Circle. This Circle even contains joining of different tables or different types of sources. We're handling them by developing more and more standalone pipelines. Problems we are facing result in some bad experiences. From user perspective, since most of our users won't get involved in development, so they have no idea what's happening. Only thing they can do is checking output data after a long time waiting. For those users who has ability to develop, they can help to build and deploy pipelines between internal components like HBase and ClearHouse. But it's also full of manual operations like requesting table and setting specialized transformation. For developer perspective, believe me, it's an operation nightmare because there are many changes and new requests from upstream. Sometimes data discrepancy won't be detected since upstream have changes that haven't informed us. So complaints coming from end users sometimes. Then we need to verify data by checking every step of transformation, which full of business logic that developer may not familiar with. Generally speaking, self-built data transformation pipeline is non-reproducible, long time consuming, and hard to debug. And there are more side effects. Because it's not easy to build high-to-high pipelines, many people in business intelligence team still using raw data instead of data warehouse table. And these non-standardized jobs are also very hard to do data governance, since there are lack of unified data metrics. So we started searching for solutions, but we don't want to reinvent the wheels. As you can see, we already invented many of them. Let's take a review about why we finally choose SeaTunnel. Before we introducing an open source tool, we always need to know the pros and cons and the boundaries. So we did some research before nomination by comparing it with other choices. Scoop has a long history, but it only supports relational databases, and it's hard to handle sharding tables by it. Besides, it has retired from Apache community already. DataX is a data synchronization tool widely used in Alibaba. It's easy to use and easy to extend more plugins, but it's not distributed for open source version, and it will bring high pressure of single machine due to its memory usage policy. Next one is Apache Hop. It is a rising sun based on Cattle or Apache Beam. It looks really nice in many ways, but it's too heavy for us. Hop aims to create a one-stop data processing platform, but what we need right now is a lightweight tool. Similar reason for AWS Glue, and it is even not open sourced, so we have to pass it. So we start to evaluating our last choice, SeaTunnel. Basically, SeaTunnel is a very easy to use, ultra high performance distributed data integration tool that supports real-time synchronization of massive data. And it makes use of Java SPI mechanism, which makes it extensible in convenient way. And that's one of the main reasons we chose it, and we really need it. And besides, it's easy to edit configuration and run the job out of the box. It supports Spark or Flink engine, and the connectors can be added and updated. Moreover, currently, community is highly active. And as you can see, configuration for application is very clean and simple. Environment defines Spark-related or Flink-related environment settings. Source defines where data comes from. Transform defines how result data will be like. And sync defines where and how data will be written into. The third chapter will elaborate things we've done in internal SeaTunnel Spark engine, and what SeaTunnel brings to end user and developers. Before we provide formal service to user, we need a way to let user do it by themselves as soon as possible, since our developer couldn't catch with their various requirements, catch up their requirements. We chose to use the Spark engine only for this temporary solution. There are two reasons. One is most of our user requirements can be dealt by batch ingestion. And second is our Flink platform didn't have project and team level management at that time, but it has right now. So obviously, user need a place to upload their SeaTunnel. And besides, user need to deploy after testing. During testing, user need a way to create and update their SeaTunnel application configuration file. Moreover, teamwork and management is important. User should be able to share their job with team members. Luckily, we have a user-friendly service called Data Studio. Basically, Data Studio is a successor of Airflow. Yeah, we're previously using Airflow, and we turn it into two services, Data Studio and Internal Scheduler. Now, user can do many things in Data Studio, such as ad hoc query using Presto or Spark Circle, and upload share script or jar to do testing, and deploy to scheduler at last. Naturally, we came up with an idea to teach user use SeaTunnel in this platform. After basic testing, we wrote user guide to support user running SeaTunnel in this service. And in the meantime, we were developing internal version of SeaTunnel. By the way, at that time, latest official version is v2.0.5. As you can see, we could deploy Spark job in Spark driver through SSH, but there are several shortcomings. Many end users are not familiar with Linux command line. Running and debugging it would be a nightmare. In this way, each member can only access their personal directory, which is not feasible for team members to cooperate. It's hard to do permission control for settings like YoungQ in Spark driver. None of these would be problems if users do it in Data Studio. Here's a screenshot of equivalent settings for the command line example. Young queue is set by underlying logic decided by which project you are. And some of other settings are default, so users don't have to fill them. So job setting looks much clean and simple. Let's take a look how user could set up a pipeline. User need to create a new workflow in Data Studio and upload the SeaTunnel Spark jar. We provide 2 ways to download the jar. You can fetch it from HDFS or Google Drive. Then user need to make sure they have access to one of our HDFS driver machine so that they can upload the application configuration. After that, fill in rest of the Spark configuration in Studio. Finally, user can do a test run. If no error occurs, user can check data by query output table or check them in HDFS and all other things directly. If everything's fine, set a scheduler time and deploy to the scheduler. There are several problems we have encountered. First one, during testing, we found that SeaTunnel Spark jar has size over 200 megabytes, but our platform only supports jar less than it at that time. So we comment out some connectors and dependencies to build a smaller jar. It also lowers the downloading and uploading time. By the way, now Data Studio support uploading much larger jar size. Another issue is some of our internal component doesn't have same version with the version of official SeaTunnel supports. So we update related POM dependencies and recompile it. After we release user guide, most issues are reported. More issues are reported. One of them is for HDFS sync connector. It won't create Hive table automatically, but user have to use the sync Hive sync will only create managed Hive table under the default path. And it conflicts with our data governance rule, which is writing data in specific paths and using external Hive table. So we add a new type of Spark sync connector called HDFS Hive table. Basically, it extends from HDFS sync and will create Hive table after data written into HDFS. Next problem is we realize that for some reason, some user cannot access to the driver machine, which means they couldn't upload a configuration file to HDFS. So we provide a new way to manage application configuration, which enable users to pass a JSON string in the Data Studio directly. It is implemented by adding an indicator called config mode. If it's set to JSON, user can pass JSON string. Actually, the JSON string doesn't as clean as simple as this dummy example shows. Actually, it contains escape character of \, and you may want to manually create an equivalent JSON file may be very troublesome. Yes, it is. So we have a small offline tool to make this transition. By the way, this way seems only feasible for older versions of SeaTunnel. In latest version, SeaTunnel has a new way to pass in this config variable. As more and more our end user come in, more and more requests come in. I listed some of them in table below. The first one, as I mentioned above, is the Hive table auto creation Spark sync. The second one is a source, which can fetch data from AWS Redshift. It's a cloud relational database, but some settings are slightly different. So we make it as a new subtype of connector. In some cases, user inquires about whether SeaTunnel already support some features inherently. but sometimes we are not sure. So we need to verify, such as whether it supports SSL-enabled MyCircle. For this case, the bright side is we work it out. The dark side is developers are still involved in, because SSL key files needs a treatment and upload to HDFS. And we are also trying to implement some of our running pipelines into SeaTunnel, such as Google Sheet ingestion. Previously, we developed the Spark data source to fetch data from Google Sheet, but we need to refactor and decouple the source and sink. SeaTunnel helped us to do that easily. And actually, we use original Spark data source and the HDFS Hive table, which is the first row in the table, as our sink. After providing a temporary solution for user to meet their urgent requirements, things are getting back on track. We start to think whether SeaTunnel can help our developer to develop and manage different types of pipelines more efficiently. One of our running system is called BTI, which is batch ingestion system. BTI solves the business analysis challenge with minimum efforts with the minimum effect on to the online OLTP system, especially when the timeline requirements are not that high. Usually, real-time and offline data requirements are about 20 to 80%. So BTI focuses on synchronizing most of the data that is not so sensitive to real-time but needs analysis. A typical BTI job is to sync data from online OLTP database to OLAP databases such as Hive. This system was suffering unstable issue and consuming us lots of time to maintain. BTI is also a part of Lambda big data architecture, as we all know. There's a long history about this system, but I'll make the background as short as possible. At the time, when we decided to introduce SeaTunnel in, we've already got rid of the airflow. So currently, they are triggered by Data Hub and internal scheduler. But executions are managed by a standalone service. This DB batch ingestion service is far more complex than the diagram shows. It contains a microservice with GUI and using Apache 9.5 underlying to manage status and relations of each subtasks in our job. And for application-related configuration, they are saved in a Git repository, which are invisible to user and hard to maintain. I won't review details of this system because it's not relating to SeaTunnel, but simplify it's also one of our motivation and goal. Here's the two main reasons why we decided to do refactor. First, since SeaTunnel has shown great potential, we're planning to use it as our long-term unified transport component. Second, we are haunted by complexity of legacy system. They are becoming fragile when more jobs are created each day. And debugging is a nightmare as well. So refactoring contains 3 subtasks. We need to re-implement original transport component by using SeaTunnel. Second, refactoring related services to reduce complexity. And last, we need to migrate history jobs into new systems because we don't want to affect them once we release the new version of it. I'll focus on the first subtask in the following slides. What original batch ingestion has to deal with? It has to support sharding tables, sharding databases, and even sharding hosts. So we need multiple Spark jobs to run it. Each Spark job is in charge of one physical database. And each stage inside the job is in charge of one physical table. We call it as a work unit. In a Spark application, a single Spark application is relative to a sub-database, also called schema. And a sub-database usually contains many table shards. If there is no data skew, means no divide needed, a subtable is synced by a work unit. Otherwise, it will be synced by multiple work units. And a Spark parallel stage can raise multi-threads to execute the syncing. And let's take a look at what steps it will contain for a whole batch ingestion job. As this example diagram shows, it includes 4 steps: fetch, partition, transformation, and table creation. Each step is a Spark application. So a BTI job is a DAG, or we can call it data flow, which consists of several self-defined steps. Among them, fetch and create table are always required. We need to check heartbeat before fetching the data from database to make sure the data quality, because we are fetching from slave DB, and it's possible that a slave is laggy. And fetch is the main step, as last page shows. It will always sync data to HDFS. As for partition, it's optional, and sometimes it's used to minimize number of hard partitions, because if we simply partition table by sharding DB or sharding host, thousands of partitions will be added and endanger our Hive metastore. Then we support some types of transformation. It needs another round of ingestion from HDFS and write data back to HDFS. Finally, there will be a certain step for creating Hive table and corresponding marker. Marker is a flag in scheduler for letting downstream know it's completed. We've already implemented batch ingestion in SeaTunnel as a plugin for source connector. Here's the what we've done. Previously, heartbeat checking was a script triggered by Apache 9.5. We can think of it as an upstream dependency. Implement heartbeat in SeaTunnel is simple. You only need to make job failed when heartbeat check failed. As for the fetch, partition, and create table stage, we move all original logic into SeaTunnel as it is. We just refactor some data structure and make sync step as a function in SeaTunnel source. The reason why we put everything into source task is that our batch ingestion job contains many data frames, since they fetch data from sharding tables. So we couldn't pass each of them down to sync connector by creating temporary view. So we came up with this workaround. It's not an elegant solution, but it works. And from the diagram, you can see there are 2 types of jobs. One is the most simple case. It fetches data into HDFS and create external Hive table and marker. This step will be triggered after fetch marker created. Then it will also generate marker for final step, which is create Hive table and final marker. And here's an example about how we use SeaTunnel to implement the equivalent job. As for the transformation, you can see a partition step is defined, but we still put related logic in the source connector. Same case for the configuration relating to sync path. As for the configuration details, you can see previously, it depends on two files. Job property defines the whole injection job, and fetch defines the fetch step. These configurations are much bigger than the content I pasted here, but after refactoring, configuration is much clearer and clean. Finally, let's see how DataHub create refactored batch injection job. The table in the right shows items of basic configuration of a task. After user click register button, this message in JSON format are passed to core engine of DataHub. Then core engine will communicate with the configuration center to get a SeaTunnel format of a configuration file and will be updated in HDFS. After job has been registered, Portal will register this batch injection job to scheduler. Yeah, so that's about it. Finally, let's see how a brand new feature being created from scratch based on SeaTunnel. Basically, apart from tools we've already provided in DataHub for standardized data sources, ETL module aims at non-standardized data injection and data transformation between data existing in warehouse. Usually, these pipelines require much more complexity in data treatment. Currently, considering the resource usage is hard to control and estimate, so we don't support multi-sources in pipeline. And security-wise, we don't let user exporting data outside of our data warehouse. And please note that, different from project that I have mentioned above, ETL product will use Flink engine. There are three reasons. We have both batch and real-time requirements. Maintain Spark and Flink at the same time will be troublesome. And Java is more prevalent internally. The third reason is there are existing mature cases of business in ETL too, like Flink X. From users' perspective, let's walk through how they create an eternal ETL pipeline. Since it's a personalized feature, it will be a bit more complex than common ingestion tool. Apart from choose and set source and sync information, users have to configure and check schema mapping rules between source and target tables. That's because schema auto-infer is not feasible after multiple times of transformation, especially for the data type. After set all configurations, user can do an ad hoc execution to see how it goes. Only when user confirm to submit the task, backend will generate the actual configuration file and let scheduler works. I'll introduce backend system briefly. There are 5 main components. DataHub is the interface to user and is the center to coordinate everything. It sends ETL pipeline creation and preview pipeline creation requests to ETL service. It creates scheduler tasks and ad hoc scheduler tasks for preview. It uses scheduler open API to get task instance information and logs. And it reads task instance status and ad hoc status from Kafka topic. Finally, job will be submitted to our Flink platform. One of the highlights that shows the advantage of SeaTunnel is the preview function. It also contains main logic of our system. Preview provides users the ability to view intermediate results. There will be two interfaces between Data Hub and ETL in the preview feature. First, Data Hub provides the current pipeline config to ETL and create a preview pipeline like normal pipeline. Instead of syncing data to real destination that user configured, we create a temporary configuration file which sync data into S3. As you can see in the flowchart, ETL services does this job and upload to S3 as well. Secondly, Data Hub needs to trigger the task manually so that the preview pipeline can create an instance in scheduler and run. So let's take a look at what the preview SeaTunnel job looks like. It's a Hive-to-Hive ETL task. It will be a widely used type of pipeline since user needed to build table in data warehouse in level like data warehouse details or data warehouse service. As you can see, both transformation and sync configuration has some minor changes. In transformation, we add limit circle script to control the size of data transmission. As for sync, destination have been changed to S3. Connector is defined in properties of think circle of table creation. And source table and target table have different paths. So user will see two tables of preview. It's much more convenient for them since they don't have to query table after a long time of execution. Now we can look back to check how ETL features solve problems we mentioned at the beginning. For the third-party ingestion, data store will centralize supported by and managed by Data Hub ETL module directly. All the data processing operations is included in the ETL pipeline. We are working on supporting and migrating more legacy pipelines to ETL platform. And from the problem of many users still using raw data ingested, now user can proceed to create a raw table to build up ODS layer pipeline in Data Hub ETL module. It's much more easier compared to the procedure in Data Studio. And ETL will not only support batch ingestion, Hive table, but also continuous ingestion of hoodie table. Similar with the raw data usage problem above, user can use ETL to build their data warehouse by creating Hive-to-Hive ETL pipelines. And last, some of the special data transmission between internal components also could be solved, like transmitting data between Hive and HBase or ClickHouse. Here's another example of how we interact and make usage of other products in our platform. User can set up data sensitivity level for each column in our data governance product. Different level corresponding for different operations. We can drop them directly, such as password or mask, part of them, such as phone number or address. So user don't have to manually set transformation configuration in ETL. And this info will be shared by all ETL pipelines which ingest data from this typical table. Okay, now we can summarize what ETL platform brings to user. Given by the ability of SeaTunnel, we can easily support more types of data stores. And users are able to learn and set up ETL pipeline in a more simple and friendly way. User can focus on data modeling and insights analysis. Compare with the temporary solution that deploys Spark application in data suite manually, ETL pipelines will be empowered more by other data suites product. Last but not least, it's engineer friendly, which means easy to operate and maintain. Okay, a brief recap from the very beginning. What we want, the solution is the solution that can solve issue we have in as soon as possible in short term, and in long term, from developers' perspective, whether it could lighten the burden of managing and operation. From users' perspective, we need to check whether it could make our product more easy to use and more powerful. Luckily, SeaTunnel passed all the tests. And we have implemented many transport components. We also refactored one of our system. Moreover, we released ETL features recently. We will continue adding more types of pipelines in it. In future, since most of our Spark applications are running in Spark 3, so as we all know, Spark 3 has a QE feature, which can automatically solve data skew more or less. So we need SeaTunnel support it urgently. We are trying to upgrade some of connectors like batch ingestion with a higher priority, and we will continue to implement more connectors. But mainly focus on Think Engine since ETL platform is our long-term plan. And we are also trying to build observability system by needs metric in every component, so that we can collect information to do unified alert system and dashboards. Okay, that's pretty much about it. Thanks for listening.